Got some information about a triangle here, and I'm looking in particular for side A, which is across from angle A. So I'm going to draw myself a picture. Angle A is 65 degrees, and it doesn't have to be perfect. I'm not getting out the protractor or anything, but I'm going to make it look closer to 90 degrees than 30, hopefully. There's angle A, 65 degrees. Side B, well, that's next to angle A, so we'll put it there. Side C is 7, also next to angle A, so we'll put it there, which means my triangle is something like that. If we try to use the law of sines here, we can't do it. We don't have the right information to use the law of sines. What I need for the law of sines is an angle, okay, I have an angle, and its opposite side. Well, I don't have side A, that's what I'm looking for. I have side B, but I don't have a measure for angle B. I have side C, but I don't have a measure for angle C. And without one of those, there's no way to find any of the others. So the law of sines won't work. Fortunately, the law of cosines will. When I have side, angle, side information, like I do here, two sides and the angle that's between them, this is made for the law of cosines. And I'm looking for the side that's opposite the known angle. So I'm going to write the law of cosines. I got the side I want, a squared equals b squared plus c squared minus 2 times each of those times the cosine, because it is, after all, the law of cosines, the angle that's across from the side I want. Once we have that, it becomes kind of fill in the blank. Let's see. So I got a squared, which is what I'm looking for, equals b squared plus c squared minus 2 times b times c times the cosine of angle A. I know everything except side A, so we should be able to figure it out. Be careful with the order of operations here. Order of operations says I'm going to do the exponents, and we can go ahead and multiply here at the same time. 2 times 12 times 7, 24 times 7 is 84. And do notice this is 84 cosine 65 degrees. So it's not 144 plus 49 minus 84. That 84 goes along with the cosine of 65 degrees. At this point, I would break out the calculator and do this on the calculator. And if a squared is all that, a is the square root of all that. So I'll go ahead and write that. A is the square root of all this stuff. And when we do that, we end up with a length of A of 11.04. And we're done. The question was find A. We found it. There it is. If the goal was to solve the entire triangle, now that I have a length for side A, I do have enough information to use the law of sines now to find either angle B or angle C. You could use the law of cosines too if you want to, but the law of sines is a little bit simpler, a little bit less on the calculator. So at this point, that's probably what I'd pick. And then once we have B or C, we can use subtraction to find the other one.